As we make our way through the refrigeration cycle, we're back at the evaporator coil. Remember, ultimately the evaporator coil is just simply absorbing heat. It's absorbing the heat from something. In this case, it's going to be air. So this video, I'm going to focus specifically on evaporator coils related to comfort cooling or environmental cooling or people cooling. We're cooling or conditioning air. So the refrigerant that's flowing through here, it's coming in as a liquid saturation mixture. And that refrigerant is going to be not just evaporating, not just slowly changing state, but violently boiling inside. The word boiler was already used, we call it an evaporator. So that refrigerant's changing state from a liquid to a vapor. And every time a substance changes state from a liquid to a vapor, it absorbs heat. So this evaporator coil is really just a heat exchanger. It's exchanging the heat from the air into that refrigerant. The heat from the air is making the refrigerant boil, but the refrigerant boiling is absorbing massive amounts of BTU, latent heat, out of the air. That's going to be saturation. If we have a TXV, it's going to try to keep saturation through most of the coil, and that last little bit will be superheated as it leaves through our suction line. The refrigerant boils from a liquid to a vapor, all latent heat, all saturation, and after all that liquid's boiled into a vapor, then we can superheat it above saturation. All that sensible, very little overall heat absorbed, but we can measure that. And if I know how much vapor I have, I can also see how much liquid I have or liquid vapor mixture I have inside my evaporator coil. So by measuring the superheat, I can get an idea what's happening with my latent heat, my saturation liquid vapor mixture. So this evaporator coil on the refrigerant side simply boils it from a liquid to vapor and then superheats it above that saturation temperature. On the air side though, and we're talking about air conditioning on this, the air side's a little bit different. On the air side, we have two things going on. One, we are sensibly cooling the air. Our thermometers, we can see a temperature change. So as the temperature of the air travels through this evaporator coil, it travels through these fins, it's warm, and that refrigerant's a lower temperature. So the heat leaves the air and transfers to that refrigerant that's boiling or changing state. So these copper tubes that run back and forth are also coated with aluminum fins. So we send that air very close. These fins are very, very close together. As we send that air through these fins, they're transferring the heat. Aluminum transfers heat very well, so does the copper, and it transfers heat to the refrigerant. And this evaporator coil is keeping the refrigerant contained, and it's keeping the air separate on the other side. So we're exchanging the heat from the air to the refrigerant. So the refrigerant boiling is going to be a lower temperature than the air, and where the refrigerant is superheated is also going to be a lower temperature than the air. They're both sensibly cooling the air. So as the air comes in warm, the air leaves cooler or less heated. So the temperature of the air physically dropped. But that's not the most important thing. Depending on what climate you're in, we're really going to need to focus on latent heat removal. So we're sensibly cooling the air, but we're also latent cooling the air. The air is going to have moisture in it. It's going to have H2O. We typically measure this with humidity, although there's better ways such as dew point. But that moisture in the air, we need to take that moisture out of the air. If we take that moisture out of the air, we dehumidify the air. As that air comes through this evaporator coil, we want to cool the air enough to where we squeeze the moisture out of the air. Earlier we talked about a dew point temperature, the point at which moisture condensates out of the air. So the refrigerant doesn't only need to be below the air temperature. The refrigerant needs to also be below dew point temperature. And if the refrigerant's below dew point temperature, as the air is coming through this evaporator coil, the moisture will condense. In other words, the air is cool, the air gets squeezed, and as it's being squeezed, it will overflow the moisture out of the air. And the moisture will collect on these little fins, and then they will ride these fins all the way down into this drain pan till we drain it outside. So we're physically removing moisture out of the air. It's considered latent cooling. And it's latent cooling because we're taking moisture in the air, it's in a vapor form, and we're making it change state from a vapor to a liquid form. It takes 970 B2s of heat energy to change 1 pound of water from a vapor to a liquid. So it's taking 970 B2s for every pound of water we pull out of the air. So as we cool a house off, we also want to dehumidify, pull the moisture out. In many cases, it's important to just simply dehumidify. We only want to pull moisture out, and we really don't want to change the air temperature much. We want to dehumidify the air without actually changing the temperature. Later, we're going to talk about psychrometrics, which is so important and so overlooked in HVAC. Psychrometrics is going to be the study of the air. As we cool the air off, the humidity level actually goes up. As we cool air, the air gets squeezed and it can hold less moisture. So if we only cool the house down, we end up with more humidity. So we must cool the house down and pull moisture out. Now, it's also very important that we size an air conditioner correctly, and we'll talk about this later as well. But if we put an air conditioner in that's too large, it will not dehumidify. And if we do not dehumidify, we're actually cooling the house down sensibly very fast. But the moisture level will be much higher, and the customers will be very uncomfortable. Like, it's 65 degrees, I should be freezing, but it feels hot and clammy. That's because humidity is a huge factor of how the body feels and how the body cools. So we don't just want to sensibly cool the air, we want to latent cool the air as well. We want to take humidity, moisture, physically take moisture out of the air, and then we drain that moisture outside. So how moist or how much humidity is in the air is going to play an effect on the capacity of the air conditioner. So as we spend energy not only cooling the air, we spend energy dehumidifying or pulling the moisture out of the air. So on the evaporator side, we're absorbing two kinds of heat. We're absorbing sensible heat, sensibly changing the temperature of the air, and we're also latent cooling the air, pulling moisture out, making that water vapor change from a vapor to a liquid, and that liquid condensates on the fins of this evaporator coil. Inside it's an evaporator coil, but outside the moisture from the air is condensing on it. So that water condensates and it runs down these fins into the drain pan, a condensate drain pan that runs out the condensate drain line and physically is removed from the house. So we're literally pulling moisture out of the air. Now in a place like Nevada, you have mainly what we call sensible cooling because the humidity is so low, we don't need to pull any moisture out of the air. A lot of times people in Las Vegas, that one time of the year when we get a rainstorm and the water starts running out of the AC units, people start freaking out. Why is there water coming out? I've never seen this before. Because finally the humidity level gets up high enough to where the AC starts pulling that humidity back out. So difference in sizing and systems between different climates. The climate you're in, which is called a climate zone, which we'll talk about later, has different effects for how you size the system as well as how you're going to dehumidify. Notoriously, people want a larger AC. Bigger's better! Rah, rah, rah. On an AC system, it's not true. You want to have a matched house system. It's called Manual J, and there's several programs now that's used with that to help size the house as well as how much the house is leaking. If you have a house air movement through it, it's going to need a different size unit than if a house that was sealed very well. There's a comfort consultant that comes out, can do what you call a blower door test, and they can run a heat load calculation and decide what size AC we need. We'll talk about sizing later on. So we know that this is nothing more than a heat exchanger. So the refrigerant needs to be lower than the air temperature to sensibly cool, and the refrigerant needs to be below the dew point temperature to latent cool, to dehumidify the air. Also, as we see, these fins are very, 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 very close together by design. The idea is that we have very little air bypass. As the air is moving through these fins, we have a lot of air touching a lot of metal. And over here on the ends, we can see how wide this coil is. The idea is that the air has to swish and move back and forth through this evaporator coil. And as that air is moving through all of these individual fins very close together, and it's moving through all the pipes, we have a decent amount of time to have good heat transfer. An AC needs to run long enough to dehumidify. Cooling the air is a whole lot easier than dehumidifying. We need to have a certain amount of run time so that we can have time to pull the moisture out of the air. Now also think about this evaporator coil being covered in moisture. When the AC system cycles off, we have something that's very important. If we live in a very moist climate, such as Florida, we want the blower to shut off with the AC because that moisture is going to stay on here and it's going to be dripping down into the drain pan and still going to be running off. The moisture doesn't just dry up right away. If we left the fan in the on position, we're continuously moving air across this evaporator coil. And as we're moving air across this evaporator coil, all that moisture that we paid money to dehumidify, to condensate on these fins, will then re-evaporate back into the air. If we continue to run the air through this, all that moisture that we paid money to collect is now being re-evaporated back into the air and is being distributed through the house. So the humidity in the house doesn't drop as much. So especially in a moist climate, you want to make sure that fan cycles in the auto position. Do not leave it on because it's not going to dehumidify as well. So also with these fins, how close these fins are together is very important because we call that a type of air bypass. We want as least amount of air bypass as possible. So the air here is being squeezed between all of these little bitty fins. So if we're moving that air through, we're getting really, really good heat transfer. It's important that we have the correct amount of airflow. And depending on the system design, we can have the blower above it. This is called negative pressure, where we pull the air across that evaporator coil. So it's sucking the air through the evaporator coil. Or I can have the blower down below and I can push the air across this evaporator coil. Whether we pull X number of CFM or we push X number of CFM, we need a certain CFM through that evaporator coil. How much? It's going to depend on the climate. If it's a humid climate, we typically want less CFM of air going through here. And if it's a very dry climate, you typically want more CFM of air. How do you know how much CFM of air? The manufacturer's instructions is a great place to start. And when we get further into ductwork and AC and psychometrics, we'll go into that in more detail. But right now, just understand that airflow does make a difference in how well this thing performs. And airflow is your #1 issue that's overlooked in HVAC. How much air we're getting across this evaporator coil is essential. Remember, we're taking the heat out of the air, and the heat from the air is making the refrigerant boil. So they are connected together. If we don't have enough airflow, we're not going to be able to diagnose the refrigeration system properly at all. If we don't have enough air to boil the refrigerant into a vapor, superheat and subcooling doesn't matter, pressures don't matter, everything's out the window because we need to get airflow first. Now we still have a long ways to go. We have to talk about airflow and different ways of checking airflow, but let's first start off with, is the evaporator coil going to be an airflow issue? We talked about aluminum transferring heat, but also let's think about dirt. Dirt is an insulator. So dirt does two things. Dirt blocks airflow and dirt slows heat transfer. So we don't want that. A mistake a lot of technicians make is they look on this side of the evaporator coil. Let's say the air is flowing in this direction. Whether we're pulling air across the evaporator coil or we're pushing air across the evaporator coil, it's going from inside to the out. There's a panel here I took off, but the air would be going from here through the coils and out of the side. What you need to check is not this side of the coil, but the underside of the coil. So this coil, if we look, ultimately it's very shiny. It looks like it's in pretty good shape. We say, hey, it looks fantastic. Let's take a look on the underside and see what it looks like. So one side looked like it was great, but if you look inside of this one, it's absolutely disgusting. There's all kinds of hair inside of there. There's all kinds of buildup inside of there. It is horribly, horribly dirty. So it's important to look on the underside. And there's several ways to do that. In the old days, we would try to work a mirror under there to see it. But nowadays, we have different types of endoscopes or little cameras on the end of wires that we can stick in there that hook even to our phone. And we can take a look up inside of here and we can see what it looks like. So if we see this kind of evaporator coil, it's not only blocking airflow, it's also stopping heat transfer. Superheat and subcooling on this system really isn't going to matter because we have an airflow issue. Even the people that will look at only pressures, this is going to be a huge issue. So seeing the airflow, checking this evaporator coil is very, very, very important. If we remove this drain pan, here we can see a few things. A lot of people will try to just clean the edge of this evaporator coil, but look at how thick this coil is. See right here on the sides, it looks like it's pretty clean here, but inside you can see that dirt has traveled all the way up inside of this coil. And this is on the bottom side, there's the least amount of airflow. If we were to take it up off at the top, you would see this dirt up here pushed all the way into the inside. So you have to be careful because I've seen a lot of people try to clean it, what they call clean it in place, and they'll try to leave the whole system hooked up and they'll try to scrape this stuff off. And what it usually does is causes more problems. It will damage these fins, and really what they do is they shove the dirt farther up inside the coil. So I try to look for signs to see if somebody's cleaned it in place before, because then I want to go further in my diagnostic. So when they've tried to clean it in place, now you're going to have to take a light and shine a light through this coil and look on the other side to see how much light you're getting through. So when you clean it in place, it can be much bigger of an issue. Now the technician a lot of times will have the best interest at heart. He's like, I'm just going to clean this in place. It'll save the homeowner some money, but sometimes it makes it worse. It may temporarily make it cool better, but now we've a lot of times ruined this evaporator coil altogether. Inside we see these fins right down here. Well, these fins are very, very sharp. I had a student once that said, what happens if I run my hands through on this coil? And I said, well, it's very simple. You'll end up painting the unit red. It just magically starts turning red. And of course, what it means is it's going to cut you because it's very sharp. Now, they're sharp for a reason. Remember, this coil is turned the other way, but we also dehumidify, so that moisture runs down the very sharp edge and into our condensate removal pan. When that water runs through the sharp edge, everything's doing good. But once we damage, even ever so slightly, or have corrosion on these evaporator fins, that moisture runs down, hits that bad spot, and starts dripping down past. So a lot of times you'll end up with a good drain line, but the evaporator is still leaking water, and the water is literally dripping off of the evaporator coil. Instead of dripping into the drain pan, it's dripping past into the blower, or if it's a negative return, it's dripping down onto the filter. So a lot of times you have a dirty filter, and so well, it started doing this after the guy cleaned the coil, and if you try to clean them in place, that is one of the issues that we really worry about. And I don't think the camera is doing this justice. I mean, this is absolutely horrible. Look at this. This one's coming off like a carpet. So some people take it like this and they'll peel this big part of it off. But if you look inside, there's still tons and tons of dirt still inside of there. Another thing about HVAC, wearing gloves is a great idea. I have a very bad habit of not wearing gloves, but you should wear gloves because you got to imagine this is all going to be wet. And as it's wet, it's going to have a smell to it. There's going to be all kinds of things growing. But inside of here, we see behind all this dirt, this evaporator coil is damaged. So even if we were to clean this professionally, because it's been damaged, as we put it back into service, and as bad as this is, it very well could be corroded. The water could be dripping off of this. So before we quote an evaporator coil clean, we want to also take a look at what's the condition of the metal. And if we turn this coil back over the other way, we can see there's a significant amount of rust. Now, rust doesn't mean it's leaking, but it is another point we want to look at. So here's a good example of what our evaporator should be. Even these little damages like this on the bottom side could cause that water to drip off of it in that point. Now, many of these are easy to fix. We can use a thin comb tool or a type of butter knife to kind of straighten some of these up, which are not too bad. But on the bottom side, it can cause water to drip out. Just because it's rusted doesn't mean it's going to leak, but I do want to note that on the customer's invoice. I want to say, sir or ma'am, we did find some signs of aging. It's rusting. It's not leaking right now, but I just do want to inform you of that. Doesn't mean we have to jump and replace this. It's just giving us signs and letting us know it's older. We don't want to rush and jump and replace this whole entire evaporator coil just because there's some rust. However, we do want to note it so they're not surprised if there is an issue. Now, see where these distribution tubes come into the evaporator coil? Most units have them all down at the very bottom side. And if it's at the very bottom side, that's usually one of the big places for refrigerant leaks. Also, every one of these U-tubes come in through the tubing that runs across. They're notorious for leaking here, especially at the bottom. Here we have copper, and then we have a brazing rod, and then we have galvanized steel, and then we have aluminum. There's lots of different kinds of metal, and we're having air move through this, which means vibrations, and also end up with moisture. So a lot of electrolysis can be happening right here. Sometimes you can fix these leaks, but most of the time it's not going to be worth it. If you figure that all of these were done at a factory at the exact same time, and I heat this up with my torch to fix this one, very easily this one could start leaking. Now in commercial units, it's much easier to do because they're spaced differently. But for residential, once you start trying to fix this leak, then you'll be back trying to fix this leak, or another leak someplace else. Sometimes you'll see where this tubing runs through, it could even be leaking in the center of the tube. You're only going to be able to see this side right here, the front side. This you can kind of see with the mirror, but this is going to be the back side. It's going to be very hard to see. So if you have a refrigerant leak on this back side, it can be very difficult to find that leak. So we're going to talk about leak detection later on, but if you have a leak over here in the center tube, do you think you can fix it? On commercial systems, sometimes it's worth it, but for residential units, it's typically never worth it because I have to cut a large hole. In other words, all of this aluminum I have to cut out of the way to get to that tubing on the inside. So even if I'm able to fix that tubing on that leak, I have a huge hole where I'm not having heat transfer. So that's going to be an issue. We talked about that condensate on the inside. It runs down through these fins and into the drain pan. So here we have our drain pan. You can see how the air flows past the drain pan to transfer heat. So the drain pan has to be made essentially with this giant hole in the center. So these drain pans, even though we can clean it out at the front side, the back side over here will sometimes be clogged up with gunk and dirt. We'll talk about how to clean these pans and how to clean these coils in another video, but I just want you to see how this general pan is built. Now this pan is made out of plastic. Most all the new ones are made out of some type of a composite plastic. The old ones are made out of metal that we just have to actually take apart and have rebuilt. Because it's plastic, when we screw our drain fittings in, this is called a field connection here. When we put this drain line in, we have to be careful that we don't crack this drain pan. One, if you push on it, too much pressure here, it will cause this pan to break. And also if you over tighten this connection, cause the pan to break, and then it's leaking water out. To replace this drain pan, you have to take the whole entire evaporator coil out because there's two screws on the very, very back side holding it all together. So typically what I do is I tighten this up hand tight. I try not to use any tools in these at all, and it's not needed for most people. And also don't put any type of glue because all that does is bond it to where you can't get it back off to do any work in the future. And you also have two different ones. One is up higher than the other, so this is our primary drain, and this is going to be used for our overflow. We're going to talk about drains a whole lot later. It's just an introductory to that side. Now we talked about leaks in the evaporator coil. You have to clarify, especially with the customer, what kind of leak it is. So typically in HVAC, we talk about leaks, we're talking about refrigerant leaking out. So refrigerant leaking out is definitely a big issue. We have to find the leak, and a lot of times in these evaporator coils, we can't fix the leak. We end up having to replace this entire component right here because the risk is too high. You spend all the money charging the customer to fix this leak, and then it doesn't work. They expect you to keep coming out and fixing it forever. So that's why a lot of people, myself included, typically we come to an evaporator coil that's leaking. Hey, you need a new evaporator coil. And many times, now that we have multiple different refrigerants out, you're going to replace the entire system so it's all a match set. We'll get into those details later as well. Still lots and lots to learn. So refrigerant leaking is a big one. That's what we're looking at replacing the coil. Now, when you talk about leaking to a customer, they're thinking water leaking most of the time. So you have to clarify. I just need to talk with you about the condition of your evaporator coil. We have a refrigerant leak, and the refrigerant's leaking out of this evaporator coil, and we have to solve that problem for blah, 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 whatever reasons. We talk about water leaks. We want to make sure that we cover condensate leaks because the customer's thinking, well, I don't have water coming out, or, oh, I have very hard water, so that's probably why. They don't realize it's water or moisture coming from the air. Now, refrigerant leaks in evaporator coil is going to be a huge issue. Now, typically, fixing the leak in the evaporator coil is simply not going to be worth it because by the time we fix one leak, another one arises and another one arises. So all manufacturers, it seems like, are having trouble with evaporator coil leaks. There's even some class action lawsuits going on right now because of evaporator coil leaking. So let's talk about some of the things that cause leaks. I've talked to some manufacturers about leaks, and they say that they've done spectral analysis or some fancy word, and they've found out that chemicals from the house, so we have more chemicals in the house than we've had before. The chemicals from the house start reacting with the copper, and it starts having pinhole leaks from the outside to the inside. And that's one of the issues they say is happening. Other manufacturers I've talked to said that they've done tests. They found out that the refrigerant's leaking from the inside out, and they're finding out that it's acid. So we have a few different things going on. Let's talk about the acid one first, because that one we know we can solve. If the installer does a proper pressure test and pulls a proper vacuum, there should never be moisture in that system. But if that installer goes with, well, it's close enough, then we have an issue. The old refrigerant used an alkylbenzoline or a mineral oil, and that oil did have an issue with moisture turning to acid eventually. But now we use polyester oil, which is very susceptible to moisture, and if we don't pull a good deep vacuum, that oil actually starts turning to an acid. That acid starts eating away on the evaporator coil from the inside out. So we start pitting and making holes in the evaporator coil on the inside. That copper is now free floating inside of a refrigeration cycle. That copper then ends up at the compressor and it starts sticking to the hottest part of the compressor. So having an improper vacuum causes the acid to eat away the copper on the evaporator coil, and it causes copper plating on the compressor. So the compressor has these moving parts and the copper is building up, making the tolerances closer and closer and closer, and it starts wearing and pulling down on the compressor. Imagine somebody's running and a bunch of people are dragging them down. That's what's happening to your compressor. So you have two different issues going on. So if we pull a proper vacuum, we should never have an issue with refrigerant leaking from the inside out, which is a big issue with the evaporator coils leaking. On the other side, the chemical side, it's important that we use as few chemicals as possible, and we use a good filter to help collect as much of the particulate as we can. On the other hand, I think that the manufacturers should be designing systems to handle a little bit more chemicals, since more and more houses have those chemicals in there, and having those chemicals in the house is another issue and another topic. But I find it really sad that evaporator coils are leaking in such large quantities all across the entire country. Evaporator coil leaking is going to be a pain. Now, when we're looking for leaks in the coil, we know that we can access the front side. The back side is very difficult to leak search, but typically they'll leak right where these little U-bends are, especially where these distribution tubes enter into that evaporator coil at the bottom where you have the most electrolysis, but they can also leak right here in the very middle of the tubing. So these days anymore, you just never know where you're going to find that leak, but typically when I have a leak search, I'll look for oil at the outdoor unit, and on the indoor unit, I just immediately start leak checking that evaporator coil, because that's a very high likelihood of where my leak's going to be. So let's talk really quick about cleaning the evaporator coil. We're not going to talk about how to, but let's just talk about some of the things. Now, we talked about cleaning them in place and that being an issue, especially with the chemicals and cleaners. Even if we pull this out entirely like we're supposed to and clean this with the proper chemical cleaner, if we don't get that chemical back off this evaporator coil, that chemical itself will be eating away on this evaporator coil. Now, I use a chemical that's a non-acidic cleaner. It reacts with the copper, but it's pretty safe. But even as safe as that chemical is, you have to severely and very thoroughly rinse multiple times to get all that chemical off, because that chemical will eat away on this evaporator coil. We talked about chemicals in the house eating away the evaporator coil. That chemical also eat away at this coil if you leave it on there. So we want to make sure we rinse that off very, very thoroughly and that we kill all the bacteria. Now, if you are cleaning an evaporator coil, you do not want to do it in the customer's yard. I like to go to a car wash, although do not use pressure on these because these fins bend very, very easily. So don't be pulling this pressure in a wand. A water hose is enough. Some people like to do it in a driveway. That makes me a little nervous, but sometimes you have to. I've done it before. But whatever you do, do not do it in the customer's yard, because what's going to happen is that chemical is going to kill their grass and they're going to be very upset. And it's going to be a very uncomfortable conversation between your customer and you and your employer. Also, if the customer has the artificial turf, you want to be very careful at as well, because that chemical will bleach their turf. And you talk about a very upset customer that spent a lot of money on their turf and now their turf is bleached. A very popular type of evaporator coil for a very long time was the A coil. So it's in the shape of an A. Some people call it the Canadian coil because it's A, but they also make a W coil. So this W coil, the idea is that we transfer heat in a very small area. So instead of having this large A, we put in more pieces, and sometimes even more than this, but we're still moving airflow through. Now, one of the catches with these W coils is we have to have a very unique drain pan. We're catching the moisture here, we're collecting the condensate here, we're collecting it here, and again here. Because there's so many different places we're collecting it, the condensate pan has to be very, very thin. So sometimes these condensate drain pans on these coils are very difficult to clean out. This condensate drain pan is made out of plastic, where this condensate drain pan is made out of metal. In the old days, you could take this when it rusted out and get a new one rebuilt. Ideally nowadays, the plastic or composite pans, it should never wear out. They should outlast the system. As long as the technician doesn't over tighten these threads, or somebody lean and applies pressure on that drain line and it snaps these drain pans. So these evaporator coils are notorious for leaking right where the distribution tube goes into that evaporator coil. And these are very thin. With these evaporator coils, you have to check between each one of these individual little A's to see how dirty it is. And we can see there's a significant amount of dirt built up in here. Completely clogged up with somebody's hair. So definitely an issue. Now, should these coils ever get dirty? No, they should never get dirty. How many times should you have a coil cleaned? Never. An AC coil should never need to be cleaned. So on these coil cleanings, if we have good proper filtration and that filter is changed often, we never need a coil clean. I've had customers before and I recommend them what filter to use. I leave a filter there for them to use, and they've come back and say, "Hey Ty, I didn't like using those filters you left me because they get dirty too fast. I went back to my old filters because they don't get dirty." The dirt's still there. Either it's going to be caught in the filter or it's going to be caught in the evaporator coil. And remember, we're going to pull this coil out to clean it, which means we have to take all the refrigerant out of the system. We have to cut our refrigerant lines. We have to cut our drain lines. We have to take this physically out while having these capped off, because we can't let moisture get into these drain lines. And we also have to cap the refrigerant lines because we can't let moisture get in there while we're working on it. We have to clean this with the chemical cleaner and thoroughly rinse this all off. put this back together, rebraze these connections while running nitrogen, and put in a new filter dryer. And we're going to have to pressure test the lines, and we're going to have to pull it down below 500 microns and let it hold for 30 minutes. So it's very expensive doing an evaporator coil clean. So a lot of companies, instead of calling it a coil clean, they call it a coil recondition. And I'm really on board with that because as much work, it's not just like we're just cleaning this thing up, oh, just make it shiny. We're literally having to pull it out and recondition it. It's a lot of work to do that. So I kind of on board with that, calling it a coil recondition versus a clean, because customers, they clean stuff all the time and nothing in their house is going to cost $1,000 to clean. Reason it's going to cost $1,000 is pretty much anytime you open any refrigeration system, it's going to be at least $1,000. You're looking at a lot of work and a lot of liability just because you open this line. As soon as I open this line, what contaminants are going to get in here? How much moisture is that oil going to soak up? There's lots and lots of variables. So anytime we open the system up, it's like doing open heart surgery. Anytime you open that heart up, hey, we're going to have some possible other issues. So we want to make sure we fix everything we can at that time. So a lot of times, if I have to do a true coil clean where I pull it out and clean it up, if it does have a capillary tube, I'll replace it with a TXV. Now in this case, anytime you open the system up, you want to look at the metering device, and at the outdoor unit, write what kind of metering device it is. And this one, it's a little tricky. It looks like a fixed orifice right here, but in reality, we have a thermostatic expansion valve in this guy. So we need to take that into account, make sure it's, so outside I write TXV. So now the next guy knows, hey, look at subcooling, and then we'll also check superheat to see if it's working right. If it is a true fixed orifice, I'll know I'm going to need return air wet bulb, outdoor dry bulb to calculate target superheat and actual superheat. And then I'll look at subcooling as a secondary. So we want to look at that whole entire system, but again, if the evaporator coil is dirty, superheat and subcooling really isn't going to matter because we're not going to be able to transfer heat like we need to. So checking the airflow, checking the condition of that coil is going to be very important. This particular brand uses an evaporator coil, and we call this an N coil because it looks in the shape of an N. So this is an N coil. And this is what we would call a cased coil. I had a student ask me after they went into the field, hey, what is a cased coil? And I realized I'd never told them about a cased coil. So really this evaporator coil is already in the box. So this box, they consider it a cased coil. So the only difference between a case and uncased is the cased coil comes in a box. So it's usually the same price. So if you don't need the box, you just slide this out of the new box, slide it into the old box, and you just chunk this or throw it away. But this is a case coil and this is an N coil. But notice we have this other drain pan on the side. This is what we call a multi-position coil. I have a drain pan at the very, very bottom for when it's upflow, but also if we turn it to the side, we'll be able to catch the condensate as well. So if my airflow is going this direction, I'll be able to still collect that condensate in this drain pan right here. Now personally, what I like to do is when it's an upflow system, I like to take this auxiliary drain pan out. A lot of people say it's too much work and that's going to be a case-by-case basis, but I like to have as much things out of the way that's not going to obstruct airflow as possible. So here I'm going to need that drain pan and this one as well. But if I have the coil sitting like this, and if it's not too much trouble, I will take this secondary coil out of the way so I don't have as much airflow restriction or airflow blockage. This coil is already going to reduce a lot of airflow as it is, and I want to make sure I have as least amount of other things causing problems as possible. They also make a coil called a slant coil. So the ductwork or the unit would be here and again on this side, and it's just one giant coil at a slant. So we're pulling moisture and heat out of the air, and that condensate runs on the bottom side. The condensate runs down into the drain pan. So it's a slant coil. It's still just one large coil. What's unique about this one is it's entirely aluminum. It's a full aluminum coil. So here our fins are aluminum, and also we have aluminum tubing running all the way through. One of the recent problems I'm hearing from technicians in the field working with these is it's not so much the coil leaking, which is an issue, as much as the connections are leaking. Now this is an older one and its connections are a mechanical type fitting where they thread together. So this coil, it wasn't as much of an issue, whereas some of the new ones, how they go from copper to aluminum is very important. And here we have another A coil. This A coil is all aluminum, but what's unique about this one is it's microchannel. And I did not even know that they were making microchannel until I went to my friend's house going through a scrap pile and I saw it and I was like, I didn't even know they made that. Can I have it? And he goes, yes. He hates them because they're always leaking. Well, almost all coils are leaking. So what I'm hearing is where we're going from copper to aluminum, that's been a big issue because one metal will expand faster or contract faster than another. So they're having a lot of leaks there. What surprises me about having a microchannel coil is I'm not sure how they get the airflow, because as the airflow is flowing through one of these fin coils, it's able to go through in the same direction. These microchannel coils, it looks to me like the air has to come up, go this way, and then go back up again. So it looks to me like there would be a lot more airflow restriction in this, but this, I'm not an engineer, it's just my viewpoint. Also, I don't understand how they get the condensate to drain, because with these little micro channels, how they do the ends, there's no lines for the moisture to run down. So I'm not sure how they've solved that problem. But one thing that's interesting is they send all the liquid in through one side, and then the micro channels are bent at the top, all the way back down to the other side, and then we have our tube coming up. So that to me is unusual. I'm not an engineer, so I don't know how that they've solved all those problems, but it looks like they're trying. We have a nice little spider web inside of there, and that is a Black Widow. And you shouldn't see one in the inside unit, but on the outdoor units, Black Widows are very popular. So when you open units up, you want to make sure you're mindful of things like that. Black Widows, wasp nests, things like that. So make sure if you're on a ladder, you're back enough. And if you have an issue with bugs, make sure you have some bug spray with you. One last coil we're going to talk about today, and that is a slab coil. These are used with horizontal applications, so the air is running with the horizon and removing air straight through this coil. The drain pan is down here at the bottom, so refrigerant lines are here. It does the same thing, we're absorbing heat out of the house and the humidity out of the house, but because it was a long slab coil, and this is a very small one, they get them huge, you'd have what we call a transition, or a piece of ductwork that went from the smaller unit to this larger slab coil, and then it went back down again to the ductwork. I like these old coils because they didn't restrict near as much airflow as some of these very compact coils that we see today. When you come up to a slab coil, you won't see that. All you're going to see is a panel like this. This is our access panel, suction side, liquid side, and also we have our main drain line and our auxiliary drain line. This one had a metal drain pan that was completely shot, and some really poor and horrible drain lines, and we'll talk about drain lines in another video. There's so much to learn. Let's just do a quick little recap. The refrigerant is boiling from a liquid to vapor. That's latent heat, that's saturation. And then the refrigerant superheated, the last part of that evaporator coil. On the air side, we want to dehumidify the air, which is latent heat, and cool the air, which is sensible heat. We want to make sure that the evaporator coil is not dirty because that slows heat transfer, and also it blocks airflow. So checking the condition of that evaporator coil is very, very important. We want to check for refrigerant leaks and corrosion, as well as the drain pan itself. We want to make sure that drain pan is clean and the drain line is clean. We're going to talk about all of those scenarios later on as we get into doing maintenance and doing repairs, but this is just a little deeper look at evaporator coils.